Case study of automobile engineering, requirements of automobile brakes. Suppose if the brake failure happen at any time, what will be the happen? That is a case study. First of all, what are the requirements of automobile brakes? First one is it should work efficiently irrespective of road condition and quality. The retardation must be uniform throughout its application. The pedal effort must be within the convenient capacity of the driver. It must be reliable and should not be affected by heat, water and dust. It should be minimum in weight. It will have long time. It should be easy to maintain and adjust. Noise and vibration are to be minimum. There should be provision for secondary brake or parking brake. Stopping distance and braking efficiency. For practical measure for braking efficiency, the minimum distance in which it can brought into rest after the brake applied. Some very important aspects about the braking system are: it is important that there is no air in the hydraulic braking system. Bleeding of the system is the means of keeping the hydraulic braking system air free. The amount of friction of material on the brake pads are very important. Replacing own brake pads is the quickest way to increase the braking power of your vehicle. The condition of the brake fluid is very vital. The braking system requires constant checking and worn and torn points should be replaced. Lubrication is a must to lengthen the life of the brake system parts. Parts of a brake system. The important parts of a brake system are brake pads, brake levers, brake shoes, brake lining, brake drums, sprockets, brake wire or line, brake cylinder and brake fluid. Components of disc brake are brake calipers, brake pads and rotors. In drum brakes are still widely used for their simplicity and economy. Drum brakes are generally expanding type brakes in which the brake shoes are expanded to make contact with the inside of the brake drum. The brake drum in most cases is an integral part of the wheel. The shoes contain a friction lining which are moved by means of an expanding mechanism. Expanding mechanism consists of a cam which on actuation pushes the brake shoes towards the drum. Braking friction is generated between the brake shoes and the drum. An adjuster is provided to compensate for wear of lining with use. One or two reactor spring is used to hold the brake shoes in disengaged position. The back plate encloses all the components and protects them from water, dust, mud, etc. The two basic configurations are widely used for the two-wheelers. These are single leading shoe brake and double leading shoe brake. Single leading shoe brake. The single leading shoe brake consists of a single cam and two brake shoes. The brake shoes are embraced with a stationary pivot points. Depending upon the direction of rotation of the drum, one shoe is called a leading shoe and the other is called a trailing shoe. The leading shoe is squeezed into the drum as the brakes are applied. This happens because the rotation of the drum tends to swivel the shoe on its pivot and turn it into the drum. This action results in a self-energized brake because the more the brakes are applied, the harder the brake shoe is forced into the drum. The trailing shoe, on the other hand, is swiveled away from the rotating drum. The advantage of a trailing shoe is that it becomes a leading shoe when the vehicle is rolling backward or when it is stopped on an uphill grade. Trail and endure motorcycle use single leading shoe brakes because these characteristics. Most street machines use single leading shoe brake on the rear to simplify the vehicle's rollback tendency when stopped on a steep uphill grade. In addition, they are simpler, lighter and cheaper than other types of brakes. Double leading shoe brake. Bigger, faster vehicles demand advances in brake designs to keep pace with powerful new engines and better handling frames and suspensions. The double leading shoe front brake emerged as the answer to stopping problems for most of these vehicles. Since more braking force is requested from the front brake, it needs a more efficient system to handle all the weight that shifts to forward during braking. All that's needed to re-engineer a single leading shoe brake into a double leading shoe system. The double leading shoe brake includes addition of another cam and some linkage accurate and adjust the shoes.